To begin our discussion of the renal system, we'll first start with the kidneys, which, as we'll come to learn, is the most active organ in the renal system. So, the blood that we want to filter that contains waste enters into the kidney through the renal artery. And the blood that enters through the renal artery will enter into a structure called the nephron, which lies deep within the kidney and is where the processes of filtration, secretion, and reabsorption all take place. So once blood has gone through the renal artery and into the nephron, it will come back out through the collecting ducts, and the waste will go out the ureter, which will in turn contribute to the filling of the bladder, and the clean blood will exit out through the renal vein. So in this figure you can see where the nephrons actually lie within the kidney. If you follow the balls at the top, which are the Bowman capsules, you can see the entirety of the nephron, and it really gives you an appreciation for how the structure really affects the function of what is going on within the nephron. And you can begin to see where the Bowman capsules are and all these convoluted tubes which are necessary in the function of reabsorption, and these convolutions increase surface area, giving more time for and more exchange between the blood and the processes undergoing within the nephron. And next we'll zoom in and really pick apart what is happening within said nephrons. To begin our discussion of what is actually occurring in the nephron, we must first talk about the glomerulus, which is this ball of capillaries within the glomerular capsule, which is actually what is putting the blood into the nephron in order for it to undergo these processes of filtration, reabsorption, and secretion. Once blood enters into the nephron, the first stage of filtration is complete because only certain ions can pass through the membrane that is the glomerulus. So once it enters the nephron through the glomerulus, the proximal convoluted tube, which as the name suggests includes many twists and turns, is where the majority of reabsorption occurs. When we say reabsorption, we're talking about the transport of molecules such as potassium and hydrogen ions out of the tubular filtrate and back into the blood. And this is important because a lot of these ions that make it back into the blood are obviously necessary for a multitude of bodily functions. Next, we move to the loop of Henle, which is where sodium exits out of the blood, or exits out of the nephron into the blood, which creates a concentration gradient that encourages or discourages osmosis based on the hydration level of the blood. So if the hydration level is low, then the reabsorption of salt into the blood will increase, creating a concentration gradient that encourages the movement of water into the blood because of such a high concentration of sodium in the blood. And if someone is overly hydrated, less salt will return to the blood through the loop of Henle, which slows the rate of osmosis, allowing for more salt and more water to move into the distal convoluted tube, which will go to the collecting duct, ultimately to be excreted by the bladder. So at this point, we have moved all of our partially cleaned blood into the distal convoluted tube. And this is sort of a last ditch effort to get the ions that we need before they are put into the collecting duct, which will go into the ureter, which will fill the bladder. And once the bladder has been filled, the waste products will exit out of the body through the urethra, which is located within the genitalia.